I thought that it would probably be the most important scientific discovery in the 20th century.
The Human Genome Project was a positive step in furthering the concept of big science in the United States, opening doors for future medical treatments and creating a new era of scientific cooperation and research.
Almost entirely funded by taxpayer money, the Human Genome Project drew much of its support from the success of Cold War programs such as the National Defense Education Act of 1958. Also creating the National Aeronautic and Space Administration, also known as NASA, the act represented a desire for the United States to fund projects with taxpayer money to increase its worldly scientific standing.
The success of the Human Genome Project was largely due to the amount of funding it received. Thanks to precedents sent by Lyndon B. Johnson's Great Society, this funding was possible. Amongst the funding it set aside for the welfare and Medicaid, the Great Society also allocated funding for arts and sciences. With the Human Genome Project, these ideals were revived and instituted as the project progressed.
After more than 40 years of tensions between the Soviet Union and the United States, the Cold War finally came to its conclusion in 1989, with the fall of the Berlin Wall. A McDonald's was opened in Moscow in 1990, and George H.W. Bush pronounced the U.S.'s arrival on a new world order.
A new world order. A world where the rule of law, not the law of the jungle, governs the conduct of nations.
To help support his vision of a new world order, Bush also campaigned for the organization of a project to sequence the entire human genome in 1988.
I will keep America moving forward, always forward.
The instructions for building proteins are coded almost identically in every cell of the human body. Deoxyribonucleic acid, otherwise known as DNA, is organized into 23 pairs of chromosomes. Within each chromosome, DNA is broken down into 4 chemicals: A, C, T, and G for short. A's must bind with T's, and C's must bind with G's. Just like binary code can create complicated programs out of just ones and zeros, the combination of these few chemicals, in their specific order, determines the instructions for how our cells reproduce and ultimately how we act.
In 1986, US scientists got together and decided that a map of the human genome would be useful for researching the genetic changes that cause cancer, as well as the effect of radiation upon humans. 4 years later, in 1990, 6 countries, including the United States, officially entered the project with a few major goals. 1. To create a complete and accurate map of the human genome. And 2. To create new tools to obtain, analyze the data, and make the information widely available. Eventually, almost 20 countries would become involved in the project, from 5 different continents.
In order to sequence the 3 billion base pairs that exist in one human cell, the Human Genome Project was split into almost 200 laboratories around the world, each responsible for a different section of a human chromosome. The labs used the shotgun method developed by William Sanger to determine the order of the base pairs, where a DNA strand is divided into sections and a chemical is used to duplicate the pieces, which are then organized into overlapping strands. From there, a chemical called Big Dye is used to detect where the various A's, T's, C's, and G's lie, emitting lights which are then analyzed by a computer. While incredibly tedious, this method allowed the Human Genome Project to create a very accurate map of the human genome. Although its public aspect ultimately became a staple of the project, initially scientists were unsure of how to release the data they found. However, at a conference in Bermuda in 1996, it was resolved that any findings the Human Genome Project discovered would be released every 24 hours, regardless of their significance.
The data would be released immediately. That wasn't the way it was before in science. Before it would have been the people who would generate the data would have held on and analyzed it and then published it. But in this meeting in Bermuda, which was between the people who were doing the genome, it was decided that it would be released 24 hours. And when they left that meeting, at that point it had been resolved. And it was actually a big step, because scientists do like to hang on to their data for a while before they release it to the public.
However, only 2 years after the Bermuda Principles were established, a private company, Celera Corporation, decided to become involved. With the goal of completing the genome at a fraction of the cost and then selling it, it was a direct threat to the Human Genome Project's stated goal of making the genome free for everyone. Newspapers compared it to a private company attempting to sabotage the Apollo program, but it also put a competitive edge into the public project.
I think the public Human Genome Project was in some ways, and it was doing okay, but it was sputtering a little bit until a private company, Celera, came in and this was in the 1999-2000 era, and decided that it would sequence the human genome itself. And it did so really quite quickly, and it really accelerated the World Public Project. And the Public Project ended up being the dominant project.
You know, the payoff is that uncertain and that far out, and that much fundamental discovery needs to be done first. You know, you're not going to attract private money into it. And then you can basically say, well, you know, so we're not going to do it.
The $3 billion the US invested could never be turned up by a private company all at one time, and it solidified the government's role as a catalyst for sparking massive scientific development. Celera's involvement signaled the public's beliefs that our genome could finally be profitable, and arguably began the huge growth of the genomics industry for years to come.
13 years after it began, the Human Genome Project was finally finished in 2003, where a map of the human genome, 3 billion base pairs in all, was completed with under a 1 in 10,000 error rate. Scientists from around the world heralded it as the capstone of big science and the genome, book of life. In addition, the public praised the data's potential for future medical wonders.
You can kind of think of it like if you were going to go from your house to Augusta, Maine, and imagine doing it with no roads. It would probably take you a lot longer. And so what the Genome Project did is essentially built the road so we know how to get where we wanted to go. And we could see all the exits on the way, which were all the genes were.
While undeniably leading to breakthroughs with new treatments, the exact success of the Human Genome Project is still up for debate. A new drug for lung cancer was rapidly approved by the FDA after the completion of the project, and the entire field of genomics was created to find new treatments and exploits of our genetic code. However, most of the impacts of the Human Genome Project haven't come from treatments, but have shown themselves in their ability to understand the biological reasons behind certain diseases and disorders.
We didn't understand previously, what caused cancer in detail, and now we can find all of the genetic alterations that actually directly cause cancer. And this has made a big difference for cancer treatment because a lot of the new cancer treatments are directly derived from understanding of the alterations in the genome.
For the project to succeed, it entailed many nations working together. Occurring directly after the end of the Cold War, the Human Genome Project aided foreign relations. As the project progressed on, more countries joined. Without the involvement of all these other nations, the Human Genome Project would have failed from the start.
As scientists, we really don't care much about national boundaries. I mean, if you ever come to one of our meetings here at NIH or elsewhere, you'll see that science is such a universal language. Let's say that we like to make these things like nationalities and what your mother tongue is or what you look like. These are completely secondary to the primary objective of getting good science done. And the Cold War, of course, was essentially the opposite. You have the world forming itself up into two blocks, either communist or not, I suppose.
I think that one of the biggest issues is the fact that we recognize it just wasn't an American project. The humans are, they're around the world, they're global. And so the idea that there really was this engagement of scientists around the world, I think led to this really symbolically the fact that it was a human project. It wasn't the American Human Genome Project. It was the Human Genome Project. It was incredibly important that the Human Genome Project represented every human.
As befits an undertaking that can benefit the whole of humankind, this project has also brought together the best of the global scientific community.
Despite the abundance of support on behalf of the project, skepticism remained. Scientists focused on other projects did not approve of the large amounts of funding the Human Genome Project was given. Feeling like their projects were being neglected, these scientists directed their frustration towards the Human Genome Project. Genomics was an entirely new science, and a very expensive and exciting one. A clear recipe for almost $3 billion of government funding.
Well, I do believe from talking to Francis and a couple of other people that there was a smallish minority of politicians who thought it was a waste of money. And even more sadly, I believe there were also some critics from within the scientific community. I assume these were people jealous that genomics was getting a lot of government funding. But I'm fairly certain that at different points they had to defend the viability or feasibility of what they were doing against people who were making noises in a negative direction. But I think one thing that helped, if I have my history right, is that President Clinton was exceptionally supportive of the whole initiative. So that certainly must have helped.
However, I am concerned, as many of you are, that there are some who will want to use this new knowledge as a basis of discrimination. A CNN Time poll this morning reported that 46% of Americans polled believe that the impact of the Human Genome Project will be negative.
With such a large scientific breakthrough, moral questions are asked faster than scientific questions are answered. A large part of the ethical aspect revolves around editing people's DNA. People naturally want their children to be smarter, more athletic, more attractive. And in theory, all this could be predicted and changed in babies. But it's a slippery slope, which begins with parents changing the eye color of their children and escalates to modifying every feature until perfection. Our DNA is what makes us human, and our kids our own. By changing our very life code, we are changing what it means to be human beings.
Remaining tensions from the Cold War, I think it was only something like science that could have brought so many scientists, so many labs, institutions across the world together, because this was a group of people to whom politics really didn't matter much, or at all, I should say. So I think it was the right thing done at the right time and in the right field.
Even in the future, changing their DNA will not guarantee that they will have any extraordinary abilities, or be different at all. Although we can make changes, it's not guaranteed that they will be superheroes.
I know from personal discussions with the President over the past several years and his comments here this morning that genetic discrimination has been one of his major concerns about the impact of the genomic revolution. While those who will base social decisions on genetic reductionism will be ultimately defeated by science, new laws to protect us from genetic discrimination are critical in order to maximize the medical benefits from genome discoveries.
While completing the Human Genome Project eased foreign tensions in a post-Cold War world, it was not a cure-all, and it created a whole new host of moral and ethical issues. But despite these factors, the Human Genome Project was still a massive medical and scientific breakthrough. Similar to the moon landing, the Human Genome Project was not just an accomplishment for an individual country, but a huge stride forwards for all of humanity.
People compared it to, sending a man to the moon, and I think that's a very appropriate comparison because, one of the things when we did do our first mission to the moon, there was a number of collaborative agents that were involved, and that was really the same for the Human Genome Project.
When they first proposed this, it was the equivalent of me saying today that I would like to get on my bicycle and ride to the moon in a couple of weeks or something.
I suppose in closing, the most important thing I could do is to associate myself with Dr. Venner's last statement. When we get this all worked out, we're all living to be 150. Young people will still fall in love. Old people will still fight about things that should have been resolved 50 years ago. We will all on occasion do stupid things, and we will all see the unbelievable capacity of humanity to be noble. This is a great day.